between normal running and full super elevation angle. So the belt is always fighting in those idlers for where it actually wants to run, and that causes higher belt edge loads and can cause you to at times spill material. Advancements in not only in belt conveyors, but in one of the main components used in the system is the belting itself. For very long, straight tunnels, and some tunnels with curves, we will use and are using steel cable belting. The two different types of belts that are available is basically steel cable or fabric belting. And it depends on the type of material that you're using, but primarily it depends upon the length of the tunnel and the plan, the alignment of the tunnel. Steel cable belting is capable of very high tensions. You can get a very high strength steel cable belt for very long tunnels, which allows you to minimize the number of booster drives that would be required on the tunnel. But the trade-off is that with steel cable belting and the very high tensions that it's capable of, you cannot negotiate very tight curves. So the curve radius has to be very long, and when you're looking at that, it is probably 2,500 feet and above for a steel cable belt. But that all depends upon the design of the system and the length of the curve plays into that also. Steel cable belting, it takes a long time to splice. It takes longer than the fabric belting. It is more difficult to repair. It is a heavier belting, but it is ideal for very, very long tunnels that are straight with minimal curves. The fabric belt has been available for years, and there have been advancements in the types of fabric belts that are available. Fabric belt can be installed very quickly into the system using mechanical splices. Steel cable belting, although there are some mechanical splices available, they're not commonly used. They're very expensive, and it's yet to be determined if they will really run for a long time. So we recommend that steel cable belt be vulcanized when it's installed, and that takes about 8 hours to do, whereas you can install a fabric belt in about 1 hour with mechanical splices. Mechanical splices can be ran for weeks, months. We recommend that the mechanical splices be removed and that they be vulcanized on the off shift. One of the things with the fabric type belt, and we use what is called a straight warp belt with the tunnel conveyors. We have developed belts now. One of the things that, and especially those of you that have saw tunnels which had fabric belts, you would see strings. And these strings can pose maintenance issues. They also can pose safety issues. Some of the things that we have saw at times is that these strings could even come off and they could trip a pull cord switch. The strings are very strong, and although to my knowledge there's never been anyone injured from a string on a belt, it could happen because these strings can some be very long and they could wrap around components or could pose a safety worked with manufacturers to develop a fabric-type belting that has significantly less strings. This belting was used at the East Side Access project, and it was proven that the amount of strings as compared to belting used in the past was significantly less. One of the things with belt conveyor systems, and as I had noted earlier, the systems that we provide, if you're actually looking at the volume of material that's being conveyed, it looks very small as to what the true volume capacity of the belt is. You want to make sure that you take care of the system. You don't overload the system. You don't abuse the belting. As you can see, the belt conveyor itself will convey very large, blocky material. However, when you do things such as this right here, put these large blocks onto the system, it's going to damage the system. These large blocks poke holes in the belt, and they damage splices, can clog transfer points, and could cause catastrophic failure. This particular belt, the reason that we were getting these large blocks onto the system were the cause was that grill bars that were originally designed for the machine were not installed. Once the grill bars were installed, then it did not allow blocks this large to pass through. If for some reason you cannot limit the size of the blocks that are coming through the head of the machine, then a grizzly should be installed at the transfer point onto the advancing tail piece, so that these large blocks do not get on the system. One of the things that we are always dealing with is conveyors in urban environments. And as I noted, the East Side Access Project is a very good reference for the difficulties of laying out and installing a belt conveyor in an urban environment where there's very, very limited space. The East Side Access Project, as I stated earlier, you had two extendable conveyors. These were working behind a 6.7 meter diameter TBM. And there were other operations that were going on within the tunnel at the same time. So not only was the material from the TBMs being loaded onto the conveyor belt, but there was material from road headers and drill and blast operations being put onto the conveyor system. This gives us a plan view of the East Side Access Project, and this is showing where the conveyors were initially installed. Here there was about 8,000 feet of pre-existing tunnel. And in this section, we put a fixed length conveyor. This conveyor accepted material from the two TBM operations. Then we had a vertical, this fixed length conveyor discharged onto a vertical conveyor, which discharged onto an overland conveyor. This was a totally enclosed box conveyor that went over top of Northern Boulevard. And then we had the three overland conveyors, number 2, number 3, which discharged onto a radial stacker in the Sunnyside yard. This is a schematic of the East Side Access conveyor system, and as you can see, there were two conveyor brought the material from the one system over, combined materials onto the fixed length conveyor, which discharged onto the vertical conveyor, onto the overland conveyor, onto the box truss conveyor, onto the radial stacker. So it was a complex system covering a lot of area. This system had all of the updates and with the PLC control and the pull cord system so that you could know when, where a fault occurred. So this was, in my opinion, one of the significant advantages and updates that we had made, which allowed this conveyor system to achieve 95% plus availability rate. We'll now show a conveyor, a short video. That video gave you just a brief overview of the Eastside Access project. And as I said, the conveyor system has documented 95% availability. The machine completed excavation in 2010. The second machine has also completed excavation and being removed at this time. The belt conveyor system will be used for excavation that they're doing there with flow headers and for some of the excavation under Grand Central Station for probably the next couple of years. We have another short conveyor video. This is Don Hickey, which was the project manager for this project. One of the recent advances that we've made with belt conveyors is that we have started to use belt conveyor systems in soft ground applications behind EPB machines. One of the projects that we had recently did was the Sacramento project, the Upper Northwest Interceptor. This had a 4.25 meter diameter machine, is relatively small diameter. The conveyor system was located in the crown mounted system. This system came out of the tunnel into an open cut